Okay, so we're going to go ahead today and begin lesson 4.6 in our Precalculus books, which talks about the fundamental theorem of algebra. And that theorem talks a lot about factors and finding zeros of equations. And so first of all, we're going to look at finding a polynomial given its zeros, example 1. And here we have says a polynomial of degree 5 such that 1, -2, and 5 are zeros, and 1 is a zero multiplicity 3, and f of 2 equals -24. So what we're going to do is we're going to find this polynomial. And first of all, we're going to write it in the form f of x equals k times x minus a times x minus b times x minus c. Because there are only three factors, 1, -2, and 5, we just need to write three factors for this. So first of all, we'll put in the values of a, b, and c. So we get x minus 1, x plus 2, and x minus 5. Now it says that 1 is a zero multiplicity of 3. That means I have to put x minus 1 to the third power here. Now our next challenge is we need to find the value of k. Well, in finding the value of k, we don't want to do the multiplication. First, we want to actually find k before we do any multiplication. So to find k, we're going to put -24 in for f of x, and we're going to put 2 in for x. And then we're going to solve this equation then for k, so we can find what the number is that really will stretch this graph out or compress this graph, so that we can see then that when x is 2, then y is -24. So we have -24 equals k times, so we get 2 minus 1 is 1, to the third power is 1, times 4, and 2 minus 5 is -3. So we get -24 equals k times, and 1 times 4 is 4, times 3 is -12. So we divide by -12, and we get k equals 2. So our function would be then f of x equals 2 times x minus 1 to the third power times x plus 2 times x minus 5. And we're going to go ahead and leave it at that right now. But you want to, in the future, you should do the multiplication. With it being to the 5th degree, that's a lot of multiplying. I'll allow you to not do that for one that large. But if it's the 4th degree or lower, then you should do the multiplication. So we'll go ahead and look at another example of this. Here, this one says that we have zeros of -3 and a 0 at I. Now, reminder that when we're talking about factors or zeros, if I have a complex 0, then I also have the complex conjugate as a 0. So in reality here, our zeros are -3, I, and the complex conjugate of I would be -I. So when I write this in factored form, then I'm going to get k times x plus 3 for -3, x minus I for the plus I, and x plus I for the -I. Now in this situation, when you do have complex roots, the first thing you are going to want to do is you should multiply them together before we put -2 in for x and -15 in for f of x. So we're going to do that multiplication. So we get f of x equals k times x plus 3. And reminder that x minus 1, x plus 1 is basically the difference of two squares. So we get x squared. And we're not going to have a middle term here. The middle term would be 0. But -I plus I is -I squared, which will equal +1. And so now we're going to go ahead and put in -2 for x and -15 for y to find k. Oops, almost put it in for k. So k times negative 2 plus 3 times negative 2 squared plus 1. So we get negative 15 equals k times 1 times 4 plus 1 is 5. So we'll divide by 5, and we get k equals negative 3. So if I want real coefficients for my answer will come from here, and we will do f of x equals negative 3 times x plus 3 times x squared plus 1. There's the factored form, and once again, like I said, that you should then do the multiplication here to find the standard form of it. So we would need to take and actually multiply x plus 3 times x squared plus 1, and then simplify it. All right, so we also want to look at example 2. Example 2 just basically talks about finding zeros. For this first problem here then, we're finding the zeros there. We would try the factor first. If we can't factor, then we'll just use the quadratic formula completing the square. And we've done a lot of them in the past, so I think you can do that. So let's go ahead and look at, I have letter 2a here, and let's look at that one first. Here they want us to find the zeros, and so we are going to set it equal to 0 when they ask us to find the zeros. And this equation is a little bit more difficult because it's got x to the 4th, but we factor this just like we would in the other equation. It's just that we're going to have x squared as our first term. So we ask ourselves, what are the factors of negative 54? Factors of negative 54, then when I combine them, I get positive 3. And that would be 9 and 6. So we'll have positive 9, since it's a positive 3, and negative 6. So we're going to set those two. If we can factor them, we will. But if we can't, which is the case here, we'll set them both equal to 0 and solve them. So on the left side here, we get x squared equals negative 9. And then we take the square root of both sides. Oops, there we go. So we end up with x squared, or x equals plus or minus. Remember, we take the square roots, plus or minus. Square root of 9 is 3. Square root of negative 9, then there's that I coming into play again, which we've been using in the last couple lessons also. And for the other part, x squared then equals 6. So we'll get plus or minus 3, and then we take the square root there, we get plus or minus the square root of 6. So, and then we've just solved that one. And then we have letter B here. Let's just take a quick look at that. And we set this one equal to 0. And here we're going to end up using the sum of two cubes, which is just like the difference of two cubes, but just a little variation of that. So we would have x plus 5. So our x plus 5, this will give us a 0 at negative 5. And then we would have to do the quadratic formula or completing the square to find this answer also. And that is something I know that you can do, that we've done plenty of too. And so we'll go ahead and leave it at that, and you should be all set.